A curve has this equation. Show that the curve has exactly two stationary points and find the exact values of their coordinates. Use integration by parts twice to find the exact value of this integral here between 0 and 4. The region bounded by the curve y equals this. The x-axis from 0 to 4 and the line x equals 4 is rotated through 360 degrees about the x-axis to form a solid. Use your answer in B part 1 to find the exact value of the volume of the solid generated. So that's the question then. So let's have a little look at it here. So part A, first of all, two stationary points for this part here. X squared e to the minus x over 4. So dy dx then, it's a product, so we'll use the product rule. U times the v dx is a function of a function e to the something differentiates to e to the something, multiplied by the something differentiated, and the something differentiates to minus 1/4, doesn't it? So that's u to v plus v e to the minus x over 4 times du, which is 2x. Okay, so that's equal to then. So what have we got? We've got an x, we've got a quarter underneath. So let's take the quarter outside, and we'll take an e to the minus x over 4 out. Inside, well, we need 8 here, won't we? 8x, and that will then give 2x as we wish, and with a minus, and we need an x squared, don't we? So this equals 0 when, well, this equals 0, which is simply take an x outside the bracket, 8 minus x, isn't it, equals 0. So there we just factorise that, and it equals 0. This never equals 0. So that tells us that x equals 0 and x equals 8. So x equals 0 and y is equal to, put 0 in here, we get 0, and x equals 8 and y is equal to 8 squared is 64 times e to the minus 8 over 4, which is 2. So the stationary points are 0, 0 and 8 and 64 over e squared. So there's part A done. Now part B. Use integration by parts twice to find this integral. Okay. Integral x squared e to the minus x over 4. So B, the integral between 0 and 4 of x squared e to the minus x over 4 dx. Let's just check I've written that down correctly. X squared e to the minus x over 4 dx between 0 and 4. So that's equal to, then, it's a definite integral, so this will be v, this will be du, so it's u, v. This integrates to e to the minus x over 4, but we need a minus 1/4 underneath, times v, which is x squared, between 0 and 4, minus the integral between 0 and 4 of u, e to the minus x over 4. The minus 1/4 underneath here can flip up, can't it, to be plus 4. So that's u times the v dx, which is 2x. So that's equal to, top value put 4 in here. The bottom value will be 0, so it's just the top value. This is minus 4 here, e to the minus 1 times 16. Take away nothing, plus 4 lots of, oh, there's a 2 there also, so that'll be 8 lots of. The integral between 0 and 4 of x e to the minus x over 4 dx. We have to do integration by parts twice, so the same again then, same process. So that's equal to minus 64 now, over e here plus 8 lots of the whole thing. So it'll be uv. So again it's e to the minus x over 4 over minus 1/4 times v minus the integral of u, e to the minus x over 4, over the minus quarter, which we can write as 1 and 4 as before. That's u times the v, which is 1 dx between 0 and 4. Close brace. This was now between 0 and 4. It's a definite integral, isn't it? So we're almost there. So it's equal to minus 64 over e plus 8 brace. Here put the 4 in, e to the minus 1. So as minus 4 comes up, e to the minus 1. The bottom value is 0 plus 4. Now this integral is simply e to the minus x over 4 over the minus quarter again, isn't it? So we've done that a few times between 0 and 4. Close the brace. So what have we got then? We've got minus 64 over e minus 32 over e for this one plus 32, and then we've got e to the minus 1, and it's a minus 4 there for the top value. Bottom value, put 0 in, we get minus, the quarter is plus 4, plus 4, e to the 0 is 1. So I think that's what it is. So we got 8 of those. What did we say? We did that, and we did, now what have I done here? It's 8 of those minus 32, and 8 times 4 is 32 of these. Okay, and that's that run through with the 8, isn't it? So what have we got? We got minus 64, minus 64 over e. Well, I'm going to combine it actually. So it's minus 96 over e. This is plus 128, isn't it? 4 2s are 8. Minus 128 over e here. Plus 128. So that's equal to then 128 minus 128 and 96 is 124 and 100. 224 over e. So there's the answer then for part B, part 1. So I'm just double checking this now because there's so much terms that it's easy to make a mistake, so I am double checking it, and I'm looking through it here and I'm happy with that term. The 8 is fine, but here when I put the top value in I get 4. This is already a 4 here, minus 4, but there's a 4 here, so that should be 16, shouldn't it? So that's 16 there. Okay, minus the 0 is fine, plus 4 of these is fine. Then, okay, so we get that. We get 8 16s here, don't we? Minus 128. So I'll put that in there. Hopefully that's the only little glitch. And then we've got 32. So we end up with minus 128 here. Minus 96 and minus 128 is minus 191. Let's just write it in. 188, 192, minus 192. Add them up, 292, 312, 320, minus 320 here. So that's better. So there's a tiny little mistake there, which when we double checked, because of a lot of calculations, then we can spot it came here, didn't it? So that's the answer then for part B, part 1. Now let's have a look at B, part 2. The region bounded by the curve here, 3x e to x over 8, and the x-axis from 0 to 4, and the line is 4, is rotated through 360 degrees. 0 to 4 and the line 4 about the x-axis to form a solid. 3x e to the minus x over 8. So I'll do a little picture here. So it was from 0 to 4, say, just illustrative purposes. This height is 3x. Yeah, 3x. B part 2. Here it is, 3x e to the minus x over 8. 3x e to the minus x over 8. Okay, so now we've formed the solid by rotating it 360 degrees. So the volume then, I'll just put it in here again. Squeeze it in here, the formula will equal the thickness of this, volume of this is sum all the disks from 0 to 4, pi r squared, pi y squared dx. And the y value is that. So part 2 then. So here the volume that we obtain is equal to pi times the integral between 0 and 4 of pi y squared. Square this, we get 9, so I'll put the 9 there. X squared e to the minus x over 8 times e to the minus x over 8. You add the powers when you times them. It's minus x over 4 dx. 9 pi times that between 0 and 4. Now I've worked out that integral. So it's 9 pi times the integral of this was what we had in the previous section, 128 minus 320 over e. What does the question actually ask for? Exact value of the solid formed. So there's what's common here. Is a 16 common? Looks like a 16 is common. This is 16 times 8, isn't it? And this is 16 times 20. So there's a 32 common. Oh, there's a 32 common. That's a 64 common. 64 times 2 and 64 times 5. So it's equal to 9 times 64 is 540 and 36, 576. And then it's 2 minus 5 over e. Lots of pi. Don't forget the pi. Okay, that looks like what it is, but I'll double check it just in case. Yeah, this is the answer here, given in the, just check the solutions and check I got it okay, which is fine, and I think it simplifies to this as well.